Space shuttle astronauts consume an average of 3,000 calories per day. One meal normally consists of a main dish, a veggie, and two different desserts. Astronauts can choose from 11 main dishes, 8 veggies, and 3 desserts. How many different meals are possible? So, from 11 main dishes, you choose one. So, 11 combination 1. When you're making one selection, it doesn't matter whether you do combination or permutation, it's the same. And then times you do one veggie from 8, so 8C1, 8C1, and then you do two desserts from 13. And now it doesn't matter in which order you ask for the desserts, you still get the same two things. So order doesn't matter here. So 13C2. So now, whenever you do combination 1, 11C1 will just be 11. You can check it on calculator. 8C1 will just be 8. And 13C2 you can see on calculator. So 13C2, 13, PRB button, scroll to combinations, enter, hit 2, enter. And then you had the 11 and the 8 multiplied by 8, so that's 88. 11 times 8. So all that multiplies to 6864. 6864. So 13 desserts, 11, 8. Okay, let's see. Oh, okay, I have this stupid thing written alongside. It's just the 6864. Okay. A salesperson must travel 6 cities to promote a new campaign. How many different trips are possible? If any route between cities are possible. So now the easiest way to think about this is you have to travel 6 cities. So when you are doing your first selection, you have 6 choices. You can go to any of the 6 cities as a start. And then after you have visited one city, the second time round, you have 5 choices. So 5 for the second. And then you have, so you know every time you do an and, it's a multiplication. And then you have 4 choices next. And then you have 3 choices next. And then you have 2 choices next. And then lastly, you just have 1 choice. And if you realize what we have done is that's a 6 factorial. So you can just do the multiplication of all these, or you can just recognize that that's just a 6 factorial. So actually, I think it was multiple choice. So you have to know that this is 6 factorial. So yeah. "25 cars start a race. In how many ways can the top 3 finish the race?" So you are selecting 3 cars from 25, but now order matters because it's not just which 3 car finish top 3, but also it's important that which one finishes first, which one finishes second, which one finishes third. So the order does matter here. So it's 25P3. 25 PRB P3. So 13800. You have 5 different video games. How many different ways can you arrange the games side by side on the shelf? So anytime you have a certain number of things and you are looking for how many arrangements of them are possible, that's always permutations. So you could do 5p5, because you have to select all the 5 from the 5, but order matters because that's the only thing that's different in an arrangement. Otherwise, it's just the 5 games. There's nothing to do. So the only thing that makes sense is different order every time you arrange them. So it's P, so 5, P, okay, let's do it again. Second off, on. So 5, permutation 5, 120.